Hey everybody, we are in chapter 4 and we're looking at section 4.2, and here what we're talking about is simplifying algebraic expressions. This is the technique in doing or changing or altering or adjusting your algebra problem, whether it's an expression or an equation, that you need to be aware of. So definitely take note with specific accuracy and focus as we look at some of these words and we look at the process. It's not really hard, but you definitely want to take care to be sure that you know what you're doing. So let's take a look at our vocabulary. So a term is each part of an algebraic expression separated by addition or subtraction. So if I had an algebraic expression like the following, let's say 3x plus 5y plus 7/3 z minus x to the second power, what I notice is that there's clumps of numbers in a way, or clumps of expressions that are separated by addition and subtraction. What this tells me is that in this case, I have a 4-term expression. So these are 4 separated terms. If I were to have something like x times 3 times y divided by z, this is actually considered one term because everything's being multiplied or divided together, okay? So it's those definitely the addition and subtraction signs that separate or show us that we have terms, all right? This next one, coefficient. When I have a coefficient, in the case that we were looking at this, in fact, I can probably just do that and grab this example down here, right? All right, in this case, when I look at, and I'm going to highlight it, let's use my fancy highlighter, I'm going to highlight the coefficient. A coefficient is a number that is being multiplied by a variable or variable term or variables. So in this case, 3 is the coefficient, 5 is the coefficient, 7/3 here would be the coefficient. Can you guess what the coefficient here would be? If you didn't guess it, I'm going to tell you. It's actually negative, oh, sorry about that, womp womp. It's actually -1 because this is negative x squared. What is x being multiplied by 1? -1. Does that make sense? So here we have coefficient is the number that is being multiplied by or with a variable or set of variables. All right, so that's what we have here. Like terms. Probably pretty obvious, but I'll tell you about it anyway. Like terms are terms that contain the same variables, or they're terms that are alike. So here I've got 2x squared plus 3x minus 4xy, let's do that, minus 5x plus 6x to the third. Now, each of these contains an x, but they are all not like terms. Like terms in this case, I'll highlight in yellow, would simply be this positive 3x and this negative 5x. Can you guess why? Their exponents are exactly the same. The exponential value on x is the same as the exponential value on x over here. And therefore, they're both the same. They're the same term. They're the same time, or they're like terms. Here, even though this has an x, it's x to the second power. Even though this term has an x, it's x times y. And this term also has an x, but it is raised to the third power. So power and the variables are very important in determining whether or not we have the same type or like terms. Another example of like terms would be 3xy plus 7xy minus 10xy. Here I'm adding terms that are alike, okay? And so all of those are alike. All right, so constant is a number without a variable. So if you have a number sitting out there in the wilderness all alone, it's a constant. Let's think about the word constant for a second. Constant means it's the same all the time, right? Variable means it changes. So let's think about it in the context of mathematics. When I have x, if I tell you to solve for x in this problem, today x might be 7, the next problem x might be -3, problem down the line x might be some crazy imaginary number. We'll talk about those later. So the point is, a variable, a letter changes, it varies, but a number standing by itself is just exactly what it is. It's constant. Let me get rid of that. It's constant. So 2 is 2. -5 is -5. 4 is 4. 1,373 is just that. So a number by itself that's not being multiplied next to a variable, those are called constants. Finally, simplest form. It's an algebraic term with no like terms. What? An algebraic expression. This is wrong, people. An algebraic expression with no like terms. Let's think about what that looks like. So if I have 2x plus 5y minus 3x plus 1, do we have any like terms here? I hope that you remember from our definition of like terms that indeed we do. This guy is alike and this guy is alike. So what we say in a situation like that is that this is not in its simplest form. In its simplest form, we combine all like terms together so that when we're done, there are no more like terms. So here, 2x plus a negative 3x, if I've got two x's and if I've got 2 minus 3 basically is what I'm looking at, I get a negative 1. Negative 1x I can write, or I could just write negative x. And then I'm going to bring along my 5y and my 1 for the right because I cannot collapse them down. I can't join them with anything else. So here, this is now an algebraic expression in simplest form, okay? All right, let's take a look at a couple of examples relatively quickly. I won't have to rush, but I think you guys will get the hang of this very shortly. So number 1, part A, it says identify like terms in the following expression. So here, all we're doing is identifying which terms are alike. I worked with somebody on this and I was trying to simplify, and that's not what I should have done. So the like terms in this case are 3x and 4x. Even though this has a 4 and this has a 4, they've got the same coefficient. They do not have the same variable part. Even though these guys have different coefficients, they have the same variable portion, and therefore those terms are like terms. If I wanted to simplify this, I would join the 3x and the 4x together to give me a grand total of 7x's. And my simplified version of this, though this is not what they were asking for, is 7x plus 4y. I just couldn't help myself. All right, let's go ahead and look at this next one, part B. Part B is 5x plus 3 plus 7x plus 4. What I'm going to do again is to identify like terms. 5x, let's make that a little bit better. 5x is also an x term as 7x is an x term. And notice here, 3 is a constant, which is a term, and 4 is a constant. So we've got two pairs of different like terms. And again, this was not required, but if you chose to simplify, what you would get is 5x plus 7x gives you 12x, and then 3 plus 4 is going to give us 7. So 12x plus 7 would be the simplified version of this expression. All right, so that's example 1. But all you needed to do in this was just to identify like terms. All right, so let's take a look. Identify parts of an expression. As I look at this, we're going to identify like terms, coefficients, constants, and expressions. So let's get started. So like terms. When I'm looking for like terms here, I'm going to just take the partners. So 6x and x are like terms, so I'm going to just jot them down there. 6x and x. Do we have any other like terms here? We don't. 5 is a constant, negative 5 is a constant, and negative 2, y is not a like term. And constants in the expression. So let's go ahead. Constants. What are my constants? I only have 1. And I'm going to write this as negative 5. Notice that the negative comes along for the ride and influences what I have. So negative 5 is my constant, not just 5. Identify terms, like terms, and constants. Coefficients. I'm sorry, I missed this word. Thank you guys for being patient. I know you were at home screaming, doesn't she see it? Coefficients. All right, I got it. So what are the coefficients? So we have a couple of coefficients. In this case, 6 is a coefficient, negative 2 is a coefficient, and negative 5 is not. But 1 is a coefficient. Negative 5 is not a coefficient because it's standing alone. It's not being multiplied with a variable at all. But 1 is technically being multiplied. I am actually hating this green right now, so I'm going to go back over this in black. My apologies, chablitos. I'm so sorry you couldn't see. Okay, sorry, babies. So 6, negative 2, and 1, because those are the numbers that are being multiplied next to variables. So do I have it? So I think I got it. I think I got them all. All right. So now that you've done that, you can move on to example 3 with me. So now we're actually going to simplify what we're so good at already. So I'm going to get started with this first one, part A. I'm looking at 4x plus 6 plus 2x. I see that I have like terms in 4x and 2x. So I'm going to bring those bad boys together to give me 8x plus 6. Now that there are no like terms anymore, I know that I'm done. I've simplified as best I could. Let's move on to the next one. Here in part B, we've got 5n plus 2 minus n minus 6. We're going to have to really be careful here. So let's take our time. We've got 5n and minus 1n. That's what that is. Remember, there's always a 1 that we can assume is being multiplied next to our variable if we have a quote standalone variable. And then we have plus 2 and a minus 6. So now I'm going to get together, join these guys together. I've got 5n and a minus n. 5n plus a negative 1n is actually a positive 4n. And then positive 2 and a negative 6 come together to give me a negative 4. So my simplified expression for part B is that. And let me do this last one. This one probably needs the most room. So here's what I'm going to do. I'm not going to erase it, but I am going to shrink it. Get it out of the way a little bit. And let's go ahead and look at this part C. So part C gives us 6y minus 3 times the quantity of x minus 2y. Now, last section we were talking about the distributive property, and we are so about to rock the distributive property, I am going out of my mind with joy. Okay, not really, but it's really going to be really necessary for us to pay attention. So watch this. This is not just a 3. It is a negative 3. It carries along the baggage right here from the front. And so what I'm going to do is I'm going to rewrite my 6y, but now when I'm taking this negative 3 throughout that quantity, I'm going to make sure and keep in mind what my sign is. So negative 3 times a positive x is a negative 3x. Negative 3 times a negative 2y, negative times negative. Remember this from chapter 2. Negative times negative is going to give me a positive. I get a positive 6y. Does that make sense? And now as I look at it, so the first thing when I'm simplifying is I want to get rid of the parentheses. After I've done that, now I can see if I can join like terms together. And now I can. I see I got this guy is the same as this guy in terms of terms. So when I bring those bad boys together, I get 12y minus 3x. Is that all right? I hope that feels good. You know what you got to do. Let me know if you're having any questions, okay? Here's example 4. It is our last example. We're going to write and simplify an algebraic expression. So here we go. You have some money in the savings account. Your sister has $25 more than you in her account. Write an expression in simplest form that represents the total amount that both of you have. So here's you and here's your sister. Let's say you've got X amount of money. I don't know why I keep choosing that purple. Let's say you've got X dollars in your savings account because we don't know. How much does your sister have? If she has 25 more than you, we know that more implies adding on. So we've got X plus 25. So let's write an expression to show how much we both have in our account. So it's going to be my money plus her money all together is going to give us our money. So, you guys see what we have to do. We've got 2 X's plus 25. This is not a situation where we're distributing because this is addition. And even if you were to think about a 1 out here, you'd be distributing in a 1, so it's overkill. So we end up with 2x plus 25. I hope that made sense. I can't wait to see you. Let me know if there's a better way for me to explain or if you see any mistakes or whatever. I can't wait to talk to you soon. Bye-bye, guys.